Hey guys, today we're going to be wrapping up section 4.2 and talking about something called conditional probability. So we've talked about the multiplication rule when we had like two things that need to happen in a row, this and then this. And then we've also talked about the or probabilities, which was the addition rule. What's the probabilities of this thing happening or this thing happening? Today, it's going to be slightly different. We're going to talk about what's the probability of something happening given that something else has already happened. So, like, what's the probability that it's going to rain today given that it is cloudy outside? So, slightly different, a little bit different notation. And we're also going to be talking about something called two-way tables. Two-way tables are a type of frequency table that will look a little bit familiar, but yet also a little bit different. So first of all, let's just define what conditional probability is. It is the probability of an event given that something else has already happened. So given that it's cloudy outside already, we know that's the case. What's the probability that it's going to rain? So our notation looks like this. Probability of A given B, or the probability of event A given that event B has already happened. So this B already occurred, already happened. So given that's already happened, what's the probability of this A thing happening? So again, a couple examples. Probability of rain, given that it is cloudy. What is the probability of, say, A on a test, given that you study for 3 hours? Things like that. What's the probability that, say, OSU wins, they beat Alabama, given that they, sorry, I shouldn't say given here, given that they score 42 points. So what is OSU's chances of winning given that they're going to score 42 points? Or given that they've scored 42 points, now what are their chances of winning? Okay, so those are some brief examples. We also need to talk about something called a two-way table or a two-way frequency table, because that's what we're going to be using to determine these frequencies. So this is just a way to display and compare basically two, or it could be more categorical values. So in the case of these two tables, the one we're comparing males and females on what type of cars they prefer, whether they prefer SUVs or sports cars. And the other one we're comparing, these are supposed to be teachers, so math teachers, English language arts teachers, history teachers, and chemistry teachers, and the beverages they prefer with their lunch, whether it be coffee, tea, water, or soda. At the end of each of these rows and columns, you can see these totals here. When you add these up, so if we're going to go, let's say column, so if we look at the male column, or sorry, row, male row, 21 plus 39 equals 60. And if we were to add the female row, 135 plus 45 is 180. And then if we were to add these two down, 60 plus 180, that gives us 240. And the same works the other way if we add down the columns. 21 plus 135 is 156. 39 and 45 is 84. Then add across there, 156 plus 84 is 240. So this represents the total number of people, total of all people. That's generally how the setup works. Same with this other one. You could add these across, 12, 5, 6, 3. You'd get 26. You could also add down 12, 10, 5, 8. You get 35. So these are called two-way tables because there's variables in both directions, rows and columns. And these are what we're going to use for conditional probabilities. So let's start by just looking at a couple examples. We're going to use that table about males and females with SUVs and sports cars to begin with, and we're going to answer some questions. The first one, just get warmed up without any of the conditional part to it. The first question is, if we just choose a person at random, what's the probability that they're going to choose a sports car? All right, so two things we need to figure out. Sometimes these are called favorable outcomes over the total number of outcomes. You've ever heard that notation before? So basically, how many people would choose a sports car, regardless of whether they're male or female? So how many people would choose a sports car? Well, we look in the sports car row, and we want the total, so males and females. So it's going to be 84. That's considered our favorable outcomes. And then we're asked for the total amount of people, so just in general, would be 240. So 84 out of 240. And let's just make all of these decimals to make sure we're all consistent. So that's 0.35. So approximately 35% of the people in this survey prefer a sports car over an SUV. That's all people. The next question is basically what's the probability of choosing a male in this survey? So what percentage of the survey were males? So we locate the male row. It's right here. Let's go over the total. The total was 60 males out of 240 total people. 60 divided by 240 is 0.25. Okay, so those are pretty basic so far. Now we're getting into the conditional part. So the key to this is an additional conditional part is this word given. Given. So what's the probability that a random person will choose an SUV given that the person is a female? So that's saying we're eliminating males from contention in this problem. We're just sort of locking in on females. That's all we care about in this particular question. So I found the best way to do this is to just circle the either row or column that specific item is what we're talking about. So we kind of want to read this backwards. Given that the person is female, meaning we only want to consider females in this. So these are the only numbers, the ones that are inside that female row. Okay, and then how many are going to choose an SUV? So then we match that up with the SUV column, which is 135. And since we're only considering females, we just want the total number of females, which is 180. So that is called the conditional probability. If we're just considering females, how many would choose an SUV? It's going to be 0.75. The next one, how many will choose a sports car given that it's a male? So in this one, all we care about is the male column, or row. So only want to look at those numbers, ignore every other number for the rest of this one. So choosing a sports car would be 39 males would choose a sports car out of the total number of males, which is 60. So we do 39 divided by 60, and we get 0.65. So females 75% of the time chose SUVs, and males 65% of the time chose sports cars. So you could definitely say females prefer the SUV, males would prefer the sports car. Last question here. What's the probability that a random person is a female given that the person chooses a sports car? So let's say we're only talking about sports car people. What are the chances that that person owning a sports car is a female? So again, we start backwards. Given they choose a sports car, so this time we're just going to circle the sports car column. And then we want the female one in that one. So that's 45 out of the total number of sports car people, which is 84. 45 divided by 84, which would be 0.535, so let's say 0.54. So 54% of the sports car people in the survey were females. And that's just because looks like there's more females surveyed than there was males. So let's look at the next one. So this one we're looking at teachers by given subject and what drinks they prefer with their lunches. So start basic. What's the probability that any random teacher prefers water? Okay. So there's no given, so we don't need to sort of hone in on one specific number. So water drinkers, favorable number. Total number of water drinkers of all teachers is 14. Over the total amount. Now this one is actually empty, so I need to fill that in. To get that, we could just add either down or across. Both directions would give us the right answer. So when we add those, we get 77. 77 total. So 77 of these teachers surveyed, 14 preferred water. All right, next one. Get it to go here. All right, what's the probability that any random teacher is a math teacher? So it's just the probability of math. So again, there's no given, so we're not eliminating anything. We just want to know how many math teachers there are. So look at the math row. Total number of math teachers is 26. And the total number of teachers is 77. So 26 divided by 77, 0.337, so 0.38. Forgot to do the top one as a decimal up there too, sorry. It's 0.18. Okay. So next one is going to be some given questions here. So some conditional probabilities. Changing up the notation a little bit. In your book, the problems you're going to do are going to have lots of these different notations. So it's important that you know how to read all these. This one reads as the probability of T given that it's a language arts teacher. So we always start with the second one first and make our eliminations. What I do is just circle ELA and the whole row that goes with it. All of ELA teachers, how many would choose T? So of those, we only care about those numbers. The T number is 8 out of 20 total ELA teachers. So that's 0.4. So 40% of the English language arts teachers preferred to drink tea. Next one, it's the probability of a coffee drinker given that they're a chemistry teacher. So if we looked at all chemistry teachers, we're saying given that's a chemistry teacher, basically what percentage would choose coffee. So what we do is we always start with the second one, chemistry. Chemistry, and we circle it. Oops. So only that row, and the coffee drinkers of the chemistry teachers were 8. Total number of chemistry teachers was 16. So that's 0.5. So half of chemistry teachers prefer coffee. Next one, we're switching it up. What's the probability that a water drinker is a history teacher, basically? Say, what's the probability of history given that it's a water drinker? So we want to hone in on water first. Water is this column. So given that it's a water drinker, so what are the chances that it's going to be a history teacher? And there is 5 that fit that bill as a history teaching water drinker. So 5 out of total number of water drinkers, which is 14. And last but not least, so it's going to be just a tad different. What's the probability of not soda given math teachers? So we only care about math teachers in this one. It's the top row. Now it says not soda. Not soda means everything else. So we're just going to need to do a bit of adding. Not soda, we got 12 for coffee, 5 for tea, so 17. Water is 6, so that's 23. Soda is 3, not including those because we want everything but soda. So that's going to be 23 not sodas out of the total number of math, which is 26. So we would say 88%, 0.88 of math teachers prefer not soda. So, all right, one more example. Start this one. There's actually a bunch of blanks here. So we're going to go ahead and just fill it in. We can do it with all the information that we're given. Just going to show you how to do that. So first one, let's fill in is this far right one. For the total, we know the total has to equal 98, and we're given one total is 33. So we just do 98 minus 33, and that gives us 65. We then can go ahead and do percussion. The men and women have to add up to give you 9, so it's going to be 4. We couldn't do the woodwinds yet. We could do the strings over there. 55 minus 13. That gives us 42. We then could do the brass because when you add it sideways, it has to add up to give you 65. And let's see, that would give you 52, 56, so it'd be 9. We then could add down the brass, 7 and 9 is 16. We then could add all the way across 55 plus 16 plus 9 is 98. So we just do 98 minus those. And that gives us 18, which means we now know the top woodwinds, which would be 8. All right. So our first question is, what's the probability of choosing a woodwind? All right, notice there's no given with this. It's just, as a whole, probability of a woodwind. So woodwinds, up here, the total number of woodwinds is 18. So that's favorable outcomes. And then the total number of outcomes is 98. 98 total people, 18 of those are woodwinds. The next one is the probability of a stringed instrument given that it's a woman. So we only want to look at the women. So this one here, I'm going to circle that row. It's the probability that's a stringed instrument. And again, ignore every number except those inside of that row. So stringed instruments in women would be 42 over the total number of women, which is 65. Good, just make these decimals real quick. Top one we get 0.18, and the next one we get 0.65. So 65% of the women apparently like stringed instruments. So assume that would be like violin, cello, bass, I guess, or guitars, whatever. Okay, next is, what's the probability of a man given it's a percussion? So given percussion, so we want to circle the percussion column. Just nothing outside of percussion matters. Percussion males, there's 5 percussion males out of 9 total. 5 divided by 9, that gives us 0.555, so say 0.56. Next up, the notation on this one is a little bit different, and that's because it's asking you something different, but I wanted to throw this in because your book does ask you about this. One of the problems you're going to do, this is the probability of brass and man. So basically, you're just identifying a single cell in this one. There's no conditional, so you're not like eliminating anything else. Just what's the probability that you choose someone out of all the people that plays brass and is a male. So you really just need to locate that on the chart. You can start with either variable. So start with brass. So in the brass column, males. Men in the brass is 7. So 7 male brass players out of the total 98 total band members. So that is 0.07. And last but not least, what's the probability that you get a woman that plays a stringed instrument? So if we can find women's here, and that one strings is 42. So 42 women string players out of 98 total. So a pretty good portion of the band are women string players. In fact, 0.43. It's 43% of the people in the band are both women and string players. All right, that does it. Just pay attention to what exactly the question's asking when you do these, whether you need to do the given part or if it's just asking you to identify one thing out of the table. Good luck, and reach out to me if you have questions.